Today we'll be talking about the n queens question. N queens 2, basically the problem of placing n queens on an n by n chessboard such that no two queens attack each other. N queens 2 is basically just asking how many possible variations there are, while n queens, the original n queens question on the code, asks for all the possible solutions to it. So I'll be doing this just to simplify it a little bit, but know that whatever I do here, you can add a little bit extra lines of code, just like a few extra lines of code, and you can get solve the original n queens. And this n queens problem is a very classic problem related to backtracking. So I'm not going to go over backtracking too much in detail here. I'm more going to represent how we can keep the states for the backtracking, because we need to know where to try and put the queens in, and an efficient way to keep the states. So rather than putting on a queen and then manually going through the rows, columns, and the diagonals and seeing which ones are taken, we can actually get all that information in one time, as long as we keep some auxiliary arrays. So yeah, let's get started. So we have 4 constraints, right? We have the horizontal, vertical, and then the 2 types of diagonals. Well, let's just say horizontally, let's just say we're putting a queen on each row, different row. So in our backtracking, we'll just keep track of which row we're on and just put only one queen there and nothing else. So this is taken care of. And so the for the rows, right, or we don't want any queens to be attacking on the rows. And so we can just get this information by keeping track of the, if we call this the I-axis and this the J-axis, we can keep track of what J's we used. And as long as we don't use any J's, then we can easily just ignore it and move on. So we have these two basically for free. The difficult problem comes with the diagonals, right? So one thing we'll sort of draw out, maybe we'll start by drawing it out on the diagonals on these squares that are drawn. This is for the 4x4 case, by the way. So n equals 4. Let's start by seeing how we would want it to be and see if we can generalize it, or just come up with some formula. So diagonals, right? We want these to be like, once we've taken one of these diagonals, we don't want them to be used again. So this would be one group. This would be another group, and I'm just counting out from 0. This would be the third group. Fourth. And then you get 4, 5, 6, basically 4 here, 5 here. Okay, so you might see a pattern now that let's put more things on the axes here. So I starts at 0 and at 3, 0 and 3. Now at this point, you can maybe tell that the diagonals, or at least this diagonal, is represented by basically I plus j. So another thing we can keep track of is I plus j. And this gives us this diagonal. All right, so the last one, it's kind of facing the opposite way, the other diagonal. So like here and so on. So we try the same thing. So let's put the axes beforehand so we can kind of tell. So this should be one group. This should be another. This should be the third. You should be one group. Here. Here. And there. Okay. This is a little harder to think about. But let's start with the zeros case, right? So it's good. We're gonna have to involve I and J somehow. The intuition for involving I and J is going to be because we're working with diagonals. So I and J are going to be involved somehow. So let's start with the 0, 0. They're not involved. So we have this extra constant 3. So we'll do 3. But notice that 3 is actually just n plus 1 or n minus 1, excuse me. So first we know that it's ij something plus n minus 1. Okay, and now that we go on to 1, for example, 0, 1, well, this goes down to 2, right? And then if we look at the end, 0, 3, it goes down to 0. And so it looks like we're just subtracting the value of j. And then we can also verify it by going down this axis, right? If I is 3, then the answer is 6. The diagonal is on is 6. So now we have our final diagonal. We can represent these with arrays and access them in basically check to see if there's any other conflicts in O one time. Let's go ahead and code this up. And so let's start by keeping track of the columns, which is just going to, we'll start with false times n. There's n columns. And then we'll have a diagonal for both of them, 2 diagonals. And we got to notice that our diagonals goes from 0 to 6. Or in this case, it's going to be 2 times n minus 1 because there's going to be 7 elements in there. So really, we can just put 2n here. But just for the sake of not wasting extra space, let's put this as 2n minus 1. And then here. All right. Let's write the DFS function. Keep track of the I here. One of the base case is when we've reached the end. So if I is equal to n, then we found a solution and there's one possible solution. Otherwise, we put every single j, or we choose a j and for basically every different spot in a row. We'll pick that and then see if it works. And so let's iterate through all j. And then let's, so here's where these arrays come in handy. So we can say if calls j, so we started off with false, that means if true, we know that there's something occupying that spot and we can't use that j. So we can just continue. But of course, we have the 2 diagonals too, right? Diag 1 and then diag 2 that we have to check. So let's do diagonal 1. Of course, we can assign them arbitrarily, which one we're going to use the 2 equations. Just to do that, let's put this here for reference. So, never mind. Anyway, one of them is going to be I plus j, right? The other one's going to be I minus j plus n minus 1. And so here we know that if any of these are true, that means another queen is attacking it. And we can't do anything about it. Otherwise, we'll set all of this to be true because we've placed the queen there, and anything that basically have to represent that it's attacking everything else that's in the same column, diagonal 1 and diagonal 2. So we'll set them all to true. And of course, we'll run our DFS. We'll go to the next row, I plus 1. And then once we finish that, you have to set it to false, basically removing the queen and trying the next one. So first we have to do that. And then at the end, our result is just going to be what we find, the sum of all of them. And so all we have to do out here is to return DFS starting at 0. All right, cool. So let's go ahead and submit this. And there we are. Thanks for watching. I'll see you in the next one.